Welcome to Jörg Mühlenhoff, Energy Scenarios Coordinator, Climate Action Network Europe, and welcome to Jonathan Bonadio, Policy Officer for Renewables, Climate and Grids at the European Environmental Bureau. Jörg, you take over the screen sharing, and let's go into the details of the PAC scenario.
Okay, hello, good morning. I'm Jonathan Bonadio from the European Environmental Bureau. Thanks indeed, Antina. Thanks to Vandal and Patrick for the introduction of the PAC scenario. I hope you can all see me and hear me well. So I have been working together with Jörg Mühlenhoff from CAN Europe on the building of the PAC scenario. I owe myself in this introduction also to thanks warmly all the people, members, stakeholders, experts, etc., academics. I mean, the list is pretty long of people who contributed to building this PAC scenario and building the assumptions. So without further ado, I'm going to briefly introduce one of the most exciting questions of this presentation is how did we do to build this PAC scenario, this Paris Agreement compatible scenario? As you can see in the slide here, it's been pretty simple a question and pretty complex an answer. We started with the first question, which is how much energy will the European Union need in the future? So reflected and based upon more than 60 studies and science and sources, we built what would the energy demand, the consumption of energy would look like in the future, with also the input of member. Then we ask ourselves, when we have built this forward-looking energy consumption, the evolution of the consumption, we ask ourselves another question is where will all this energy come from? And this is where once again, based upon the studies and discussion with stakeholders, we try to build this sustainable, fully renewable energy system to match the demand. What we did in this scenario, in this first step, the overall philosophy of building the scenario is really about having a balance between how we produce energy and how we consume energy on a yearly basis to have the sufficient amount of energy for our yearly consumption. Based on this, of course, our guiding principle, where, as Vandal has presented, the climate and energy targets in renewables, greenhouse gas reduction, and energy efficiency gains, and we checked the overall scenario afterwards towards these targets by 2030 and 2050 in order to see if it indeed matches our goal of the Paris Agreement. As it was said before, I mean, I think it's important. It was not an ideological build at first. It was really a way to answer the question: is it actually possible to have a swift transition to 100% renewables and to match the demands of the Paris Agreement, of the IPCC in terms of greenhouse gas emission, with the vision, of course, integrating the vision of civil society. So last but not least, there was one important point. Jörg will introduce it afterwards. We also wanted, once we ask ourselves and reply to the question, is it physically possible? Is replying the question, will the lights, will the heating keep on at every hour of the day with such a renewable scenario? Jörg will present you the results. I don't want to do any spoiler here, but we have a very good and positive answer to this question as well. Without further ado, a quick overview on the first question that we ask on the next slide, indeed. Thanks, Jörg, which is how much energy will we need? I don't want to go into the details. Jörg will introduce the sectors afterwards, but the core message from the PAC scenario building is that we can divide by 2 our energy demand between now and 2050, thanks to energy efficiency measures, thanks to lower demand, thanks to optimization of processes, thanks to electrification of sectors, and we'll present you the sectors afterwards. Now, in the next slide, to go a bit more in details, because you might all ask, well, where does all this energy come from if we have a fully renewable system? So, very nice tautology, all energy is renewable. So basically, fossil gas, fossil oil products, and coal would be phased out before 2040, as you can see with an incremental phase out in this graph. The core message is as Claude Turmes said in the introduction, we will need electricity. This is by construction. This is not an ideology. When we started the scenario, we were quite agnostic towards electricity as an energy carrier, but we have to witness that when we phase out fossil fuels, we need extra energy supply from renewable electricity, also for heat from heat pumps, and also a bit for flexibility in some sectors from non-fossil gases and fuels such as hydrogen. Voila, I think it was a nice teasing. I will let Jörg complete and go into a bit of deeper analysis of the sectors and how the demand for sectors would evolve. Thanks indeed, and Jörg, the floor is yours.
Yes, thank you very much for this introduction, and good morning also from my side. Let me now guide you through the distinct sectors that we assessed together with members and experts. First of all, most important sector is, of course, industry. In the industry sector, the big headline is the circular economy approach. Circular economy means that, amongst many other things, we will reduce the material demand. The material demand will change, and that leads to a decrease in energy consumption. We are mainly based here on the findings of the material economic study that was published last year. We took over many of their assumptions and data. And we also assume that many production processes in industry actually can be electrified for those sectors that cannot be electrified with renewable electricity. For example, in the steel industry where high temperatures are needed, we assume that renewable hydrogen will be introduced in these specific industry sectors. Now, when we look to the buildings we are living in, the picture is completely different. In the residential sector, the big headline is the deep renovation wave. The deep renovation wave means that while we are currently only renovating 1% of the building stock in Europe per year, we will and can increase this share to 3% per year based on findings of the EU Calc project and of Fraunhofer ISI study that we introduced into our scenario building process. This deep renovation wave is not only an opportunity to reduce the energy demand of the buildings we are living in, it is also an opportunity to replace the inefficient fossil fuel boilers in our homes with more efficient electric heat pumps, or with a connection to a district heat network that would then bring the renewable heat to the houses. When it comes to the office buildings, to public buildings, the buildings we are working in the tertiary sector, the same principles apply. You see more or less the same trends based on these assumptions, with the difference that the electricity share here is higher because of the higher importance of the information and communication technologies in office buildings. Let me briefly introduce you to the smallest sector in terms of energy demand, which is the agriculture sector. In the agriculture sector, the big headline is a switch from fossil oil products that are used in farming machinery and other processes to renewable electricity and mainly bioenergy, which in the case of agriculture is just a circular use of residues of byproducts that anyway occur in agriculture, so we can harvest an important bioenergy potential without questioning sustainability criteria that we also discussed. I will hand over for the last sector, for the transport sector, to Jonathan again.
Thanks indeed, Jörg. So very brief overview of the transport sector, because I think this is a very important big picture, second energy consumer after energy production. This is a core sector and also challenging to abate and to transform into fully renewable. The big lesson from the transport is that if we want to match our targets and our goals, Paris Agreement compatible and net zero 2040, we need to move from 90% fossil fuel driven consumption into a fully renewable in 20 years. This is, we are aware of the challenge which is behind this, and therefore we assume in the PAC scenario, and I think it was an important philosophy of the whole PAC scenario beyond transport, we try to use as much as possible existing viable and proven technologies. And in the field of transport, the most efficient way to decarbonize a sector which is heavily reliant on combustion engines, on fossil fuels, 90%, was through electrification, with batteries for individual vehicles, for passengers, potentially with e-highways, catenary airlines, with a modal shift to train for freight, and with for sectors which are the more difficult to decarbonize, long distance shipping, long distance freight, heavy freight, and aviation. We can think indeed of non-fossil fuels. There is one important question which I allow myself to answer, anticipate some questions. Also, the philosophy of the PAC scenario was to keep, in a way, the same level of, a comparable level of services, energy services than the current system, which means that, let's say that we keep the same temperature in houses, we keep basically comparable distance with, of course, modal shift, but we try to keep the same level of services because data were more available, and also because we wanted to show that it is possible to actually switch to fully renewable while keeping more or less the same level of energy services. So voila, this is the big lesson of transport. It's possible to, with indeed a high electrification. Of course, there are a lot of details I'm happy to discuss afterwards. Thanks indeed, and I'll leave the floor to Jörg again.
Yes, and as you have seen in all these sector-specific charts that we presented, the blue slice for electricity is quite important. You might ask yourself now, how much electricity actually do we need and where will it come from? With regards to the electricity mix, very clearly, we have to first double the electricity generation to feed the electrolyzers that will produce renewable hydrogen, and also to charge, for example, the batteries of the electric vehicles. But this is feasible to double the generation between 2015 and 50 because we can tap our own domestic European solar and wind potentials easily as the cheapest source of electricity. You will ask yourself also, well, with an energy system that is based on a very high share of renewables that depend on the weather, is this system still stable? Will it work? For this reason, we fed our numbers into an electricity market model run by Öko-Institut. And the good news about this is that all the additional demand that I just mentioned, for example, the batteries, the electrolyzers, they will be also a flexible demand. They will function as a flexibility option in our future energy system. When you look into the results, into the future, as Laszlo Varro from IEA just mentioned in the beginning, it is not just a copy-paste exercise, this switch towards a renewable energy system. We need much more flexibility. And this flexibility, I will guide you through those flexibility options. It will make sure that we can keep the lights on and the houses warm. I will guide you clockwise through these different flexibility options. First of all, of course, around wind and solar, we will have fossil capacities that still will run in the future, but they will reduce their electricity output in order to avoid that grids will be congested. The grids anyway, of course, will have to be expanded on a cross-border level, but also in particular on the distribution grid level. And we can use this infrastructure in a much more efficient way. Whenever the sun is not shining and the wind is not blowing, there are, of course, other renewable energy sources that can fill the gap in that case, like biogas or hydropower. And likewise, consumers, be it households or industry, also will ramp up or ramp down in a flexible way their specific energy demand. And of course, they will need to be rewarded for that and get the right signal at the right moment in time to ease the infrastructure. Last but not least, storage is very important. It's key in this PAC scenario that we ramp up massively the capacity of solar PV prosumer batteries and also flexible electrolyzers that will absorb the excess renewable electricity. So this is the picture of our future system built around flexibility, There are many options that are already in use. This is a conservative approach, science-based. We mainly rely on technologies that are already introduced into markets that are mature, that we can scale up immediately. Let me summarize. So you see here now our Paris Agreement compatible energy scenario. That is our pathway for Europe to be compatible with the Paris Agreement towards net zero emissions by 2040 in a 100% renewable energy system. To the businesses, we suggest you to read this scenario also as an investment plan for the green recovery. And regarding policymakers and grid operators, please also consider these elements as the guiding elements for energy infrastructure planning in the future. Thank you very much. We, of course, are looking forward now also to answer to your questions.
Thanks a lot, Jonathan. Thanks a lot, Jörg, for this very insightful presentation. Some of you in the audience will say, I need to look at the scenario again straight away. It's online. If you go to the PAC web page and scenario development, you can find all the details. Those of you who are generally very much into scenarios, let me share that there's also a couple of high-res interesting scenarios that have been developed by TSOs that you can find a link to as well online, or reach out to us in case you are interested. We have had quite a bit of activity starting already in the poll everywhere. And I will just get going and asking questions to the two of you. We may have to shorten the time a tiny little bit. You guys were super punctual. Beforehand, we had some more flexibility in the interpretation of the watch. The highest ranking question, as far as I've seen, is actually not even phrased as a question. There is the proposition that TYNDP scenarios are already Paris Agreement compatible. Can you explain how your PAC scenario is different and really Paris Agreement compatible, and where your concerns lie with the scenarios that are in the TYNDP? Shoot up a hand if one of you wants to go first. Otherwise, I have to pick, and I would say Jörg.
Yes, thank you for this question. So the difference of our PAC scenario with regards to existing official scenarios like the European Commission's long-term strategy published in 2018, or the current 10-year network development plan scenarios. The big difference is that, of course, this scenario is much faster. As Claude Turmes initially said, we have to be much faster to be in line. And Wendel also explained that the United Nations Environmental Programme in their emission gap report also tells us that we have to ramp up ambition and be more speedy with regards to reducing our emissions. There is another big difference, which is also relying on technologies. We basically here in our PAC scenario introduce renewable technologies, energy efficiency solutions that are already available, that you can ramp up and scale up just now immediately without waiting for technologies that are potentially questionable, like carbon capture and storage, where we do not yet see a broad market introduction compared to renewable energy technologies or energy efficiency solutions right now. That is why we suggest indeed to consider these elements and to enrich the current studies like the TYNDP scenarios with more variety, with more variation. This is also learning from the consultation process with the grid operators, that it would be good to also consider a 1% renewable energy scenario in order to prepare our infrastructure for the future and avoid stranded assets, of course.
Super, thanks a lot. Then the next one goes to Jonathan. Jonathan, does the PAC scenario follow the National Energy and Climate Plans?
Thanks indeed for the question, Tina. I think the answer to this question is pretty simple. In a nutshell, the PAC scenario has used member state inputs, but the PAC scenario is way more ambitious than current or previously presented at the time of building in 2019 than national energy and climate plans. I mean, we use them at the baseline also to start the building of the energy supply and demand. But of course, as Jörg explained, in order to follow the pace, at least for the energy system, we needed to have ambitions which are higher than the current sum of the national energy and climate plans. Voila. Maybe Jörg could complete on it further, but I think this is
Reading. Yeah, looks like Jörg is fully happy with your answer. Comment in between, there is a high-ranking question which is about transparency, open source, open data, etc. The PAC scenario is going to be open data. There will be a link on the webpage. I don't know if we already have it, but if it's not there quite yet, it will come where you can access the data, because it's meant to follow exactly this ambition that this type of work needs to be accessible, usable for everyone. The next high-ranking question I have right now, and this one goes to Jörg again, is: do you consider importing renewable hydrogen into Europe?
Thanks for this question. Indeed, this question was discussed at previous scenario workshops with our members, with experts, with industry representatives. And our position is that we do not include or assume any imports of any kind of hydrogen from third countries beyond the European Union into the EU, because we think that, first of all, it is the job of the European Union to cover its own demand with own resources, to stick to its commitments, and to try to reach the targets that the EU committed to with own domestic resources. Our scenario shows that this is feasible. It is possible. The technologies and the renewable energy potentials, they are there. They are available here within the European Union. However, of course, if a further detailed market assessment shows that imports might be more attractive, this could be possible in the mid or long term. This is a question that still needs to be considered and needs to be researched. For the time being, we did not include it. And of course, whenever it comes to imports, be it electricity, be it raw materials, be it hydrogen, of course, sustainability criteria need to apply. We need to really check in detail to what extent those imports from other countries do not harm the environment, do not add any harm to the planet and to the people, of course.
Good. Last question to Jonathan, and I'm actually going to combine two questions. The question is on transport sector energy demand and whether the reduction that you assume actually includes the assumption that there will be changes in behavior. And I would like to combine this with a question on options for citizen participation in the transition. Jonathan, last question, last answer.
Thanks, indeed. This is a very important question, which, as I said, goes even beyond transport. As is it only about the energy supply, or is it also about the adaptation of demand? So on transport, to reply, the transport sector has been developed using a lot of input, but especially 5 studies from transport and environment, and with inputs of the stakeholders. To reply to this question, there is modal shift. There is active mode in the PAC scenario, and there is also an increase in efficiency of passenger by car, so increasing the number of passenger by car in the via carpooling. To go a bit, this will be the only time I would be nerdy on this panel, but we have a couple of numbers. We have 12% of modal shift to active mode, for instance, especially for urban transport, and we have beyond 10% of increase, for instance, of passengers per car. We have a reduction in the freight growth due to circular economy, etc. There are. No, I think this is important still to remind that the PAC scenario indeed assumes still a continuation of their services, which means that when we say less commuting, we are keeping more or less, even with higher efficiencies, with more active mode, with modal shift, the same number of kilometers per passengers. Not, of course, measures and policies to foster behavioral change are important, and they need to be implemented, and they are factored in the PAC scenario. But the data we had, and also the philosophy that currently we have, that of course could be further developed, was to say we want as much as possible to show the possibility of 100% renewable while keeping the same level of activity. But of course, it is absolutely of utmost importance that we have policies for modal shift for train. We have policies for decreasing the transport demand, and decreasing also the overall demand for energy services. But well, this is, I hope this answered. But I think it's indeed, I mean, thanks for the question, because it is a very important one.
And thanks to the two of you, that was super insightful. Very dense, and of course we did not answer all the questions that came in. You perhaps have a chance, the audience, to still ask them in the second Q&A round. Otherwise, don't hesitate to send questions to us. Contact data is online. This entire consortium understands the PAC scenario as a living document, and I think it has become clear that there are many questions that still need to be answered. If you have comments and further views for us, we have established a feedback section on the PAC webpage. You can see now where this is. Go on this commentary function and let us know what you think after you have read through it. We really understand this event and this launch as the beginning of a further exchange, and not as the end of what has already been a very big piece of work. So help us to continue this exchange by leaving your comments, letting us know that you are interested to talk, and we will definitely try to build upon all of this also in the future.